Well, welcome to solving a nonlinear system by graphing. Now, first of all, what do we mean by a system of equations? Well, I've written the definition here. A system of equations just means more than one equation. Now, that's usually just two equations in grade 11. Now, finding the solution of the system of equations means you're actually finding a point or points. And they all do one thing. They work in all of the system equations. So let me just show you what I'm kind of talking about here. Let's say we had a system that looked like this. X squared minus y equals negative 4. And let's say the other equation was 5x plus 2y equals 15. Now, it turns out, and I've worked this out ahead of time, that 1, 5 is a solution to this system of equations. And what that really means is if we replace the x's here with a 1 and we replace the y's with the 5, in both equations we get the left side equaling the right side. So let me just prove that to you. If I take the top equation and I plugged in a 1, I'd have 1 squared minus 5, and in order for this to be a solution, it's got to equal negative 4. Well, I think it's pretty clear that 1 minus 5 is negative 4. Now I'm going to do the same thing in the second equation. So let's put a little separator there. If I plug in the 1, so 5 times 1 plus 2 times 5, it should equal 15, and in fact it does. 5 plus 10 equals 15. So that is a solution. It works for both of these equations. Now the method that we're going to use today is graphing. So what would be involved is I would have to graph both of these equations, and that's going to be how I find the solution. Now to understand that, I'm going to get a fresh new example here, and we're going to try to solve the following. So we're going to solve y equals x squared minus 2, and the other equation I kept very simple, y equals x. And we're going to solve by graphing. So what that means is I have to graph each of these equations. Now the first one I see is quadratic, and I see that I'm going to locate its vertex. Should be pretty easy to do. Okay, so the vertex here, there's no shifting around left or right, so I think 0 is going to turn the squared stuff to 0. And if I plug in 0, then I get negative 2. So that's pretty good as far as the vertex goes. Then I think the next thing that would be helpful is to find the x-intercepts. Okay, so all this is needed to graph this first equation. So let's see, that would be y equals 0, and that equals x squared minus 2. So this one's very nice to solve. So we bring the 2 over, and then we square root both sides. So I'm going to get plus or minus root 2. And that equals x. Okay, so I can go ahead and graph this. So let's just do that here. So I'll try to draw a reasonably straight line, and same thing across here. And so we have our vertex at 0, negative 2, so it's down here. And the point root 2 is just over 1. Okay, so it's like 1 and a little bit, it's either 1.4 or 1.14. I can't quite remember. But anyway, it's around here somewhere. That's close enough for our graph. If I had my calculator handy, I'd do a more exact job. So this is our graph. So I'm going to try and draw this fairly well. Okay, slow and steady gets a steady graph. Okay, a little wobbly, but not too bad. Let's try to patch up this side here. So, okay. Now, here's the thing about graphing. all the points on the graph, wherever they may be, like this point up here, and this point here, and this point here, all the points have one thing in common. They make this first equation work. They're the collection of points that work for this equation. And they're the only points that work. That's basically what a graph is. It's all the points that make the equation true. So now when I go ahead and I graph the next one, and by the way, y equals x is a line, so I'm just going to use a quick table of values to graph that. I just need a couple of points. So I could plug in 0, 0, maybe 1, 1, and 2, 2. That's more than enough points. So we got 0, 0, 1, 1, and 2, 2. So it's sort of up there. So our line looks something like this. Okay? And it goes roaring off this way as well. Okay. Now this second graph is the collection of all points that make the second equation true. And what we're looking for is points that make both equations true. So how do we solve by graphing? Very easy. We find the points that are on both graphs. And then we try to determine what is the coordinates of each point. And they are the solutions. So the first point over here on the right, this looks like about 1.8. And it's got a y value here of, looks like maybe, well, let's see, this is supposed to be 2. So it might be also about 1.8. Okay, so that looks like that's approximately what this solution here is, this point of intersection. And then we do the same thing down here with this other point. This looks like it might be -1, -1. Okay, now, probably those points don't exactly work. And that's one of the drawbacks of solving by graphing. You know, unless you have computer software or a graphing calculator to do a totally exact job of this, this is as good as it gets. You know, we're doing a pretty good job, but not necessarily that super exact. So, conclusion, how do we solve by graphing? Well, let me just explain step number 1. You create a graph of both equations. So graph both equations, okay, using all the tricks you've been taught. If it's quadratic, you're probably going to want to use, so I'll just say if it's quadratic, probably going to want to find a vertex and followed by x-intercepts. Probably that's your easiest. Sometimes a y-intercept is a speedy way to get a good graph. If it's linear, you can either use slope-intercept form or even just a table of values. So that's either or, so table of values, or you can use the slope-intercept form, y equals mx plus b. And once you've done that, once you've got your two graphs, then you locate all intersection points. Okay. Now keep in mind, not all graphs have intersection points. Okay, and what does that mean? Well, then there's no solution. Okay, so this is assuming that there are intersection points. If there aren't, then it just means that the graphs, the two equations simply have no point that works for both, and there would be no solution. So that's where I'm going to stop today, and we're going to come back with more stuff. So, okay.